Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.81. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.81. Find voltage Vs in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find total supplied voltage labeled as Vs. Data that is given inside this network is voltage across this 4 kilo ohm resistance, and it is a series network. So with the help of this 4 volt and the value of resistance, we can calculate current through this resistance using Ohm's law. After calculating current through it, this same current will flow from this 8 kilo ohm resistance as well because of series connection. Whenever we will have the value of current through this 8 kilo ohm resistance, voltage across this resistance will also be calculated. After that, we will apply Kirchoff's voltage law inside this closed loop to calculate total supplied voltage that will be equal to the sum of both voltage. So first of all, apply Ohm's law on this resistance to calculate current through it. For that purpose, we will divide V0 with 4 kilo ohm. Value of V0 is 4 volt and the value of resistance is 4 kilo ohm. So the value of current through this resistance will be 1 milliampere. Now this same current will also flow from this 8 kilo ohm resistance as well. And the direction of current will be clockwise because we are following passive sign convention theory. According to this theory, current entering terminal of a resistance is taken with positive sign and current leaving terminal is taken with negative sign. In order to enter from this point, the direction of current should be clockwise direction in this network. So modify the network by mentioning the value of current along with its polarity in this network. Now calculate voltage across 8 kilo ohm resistance because current through it is calculated. Voltage of 8 kilo ohm will be the product of 1 milliampere and 8 kilo ohm. Milli will cancel out with K, only 1 and 8 will left, and the product of 1 and 8 will be 8 volt. So 8 volt will be appearing across this 8 kilo ohm resistance and the polarity of voltage will be positive terminal here and negative terminal here because current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign. Now we know value of voltage across both resistances. So we can use Kirchoff's voltage law to calculate total supplied voltage. For that purpose, we will write KVL equation of this network. Start from this 4 kilo ohm resistance, current entering terminal is positive. So voltage across this resistance will be taken with positive sign. Voltage across this resistance is 4 volt. So 4 volt will be taken with positive sign. Next element is voltage source. Current entering terminal is negative. So voltage of this voltage source will be taken with negative sign minus Vs. Next is 8 kilo ohm resistance. Current entering terminal is positive. So 8 volt will be taken with positive sign. Now add 8 volt and 4 volt together. Their sum will be 12 volt and place minus Vs on the other hand side of equal to calculate its value. So the value of Vs will be 12 volt. This was exercise problem number 2.81. Thank you. See you again in next video.